Okay, this is warm-up number 2 in geometry. So I've got a binomial squared. So again, the common mistake, this showed up in the last warm-up, is that people will just square both terms, but that's incorrect. You want to think of this as x plus 5 times itself. Okay? All right, and then I'm going to FOIL this. First, outer, inner, last. So first, the pieces in front of their parentheses, x times x would be x squared. Outer, the pieces on the outside, x times 5 is 5x. Inner, the pieces on the inside, 5 times x is 5x again. And then last, the pieces at the end of the parentheses, 5 times 5 is 25. Add together all the bits. And then we do have some like terms in the middle. So the correct final answer is x squared plus 10x plus 25. So if you just square both terms, you miss out on that middle term. Okay. All right, next up, we're going to find the length of this line segment. Okay. So we're going to need the distance formula. We're looking for the length. So the distance formula, we're going to use this a lot in geometry. So you've got a big square root symbol. We're going to take the difference of our x's. So notice where that 2 and that 1 are. They're not parentheses. They're not exponents, sorry. They're down there. They're little footnotes. This just means this is my second x and my first x. And actually, you could switch the order of those two x's. It doesn't really matter. But you want to subtract the 2 x's in there. And then I want to subtract the 2 y's in here. Okay? Now, it doesn't really matter. The distance from A to B is going to be the same as the distance from B to A. So it doesn't really matter which direction you measure from, right? You could set your ruler at 0 over there or 0 over here, and you'll get the same measurement, okay? So I'm going to call the point on the left my first point. So that is going to be x1 and then y1, okay? And my second point, this is going to be my second x and my second y. Okay, and when I say this out loud, I'll sometimes say x sub 2, y sub 2, and x sub 1, y sub 1. Okay. All right, so let's put that into the equation here. The distance between these 2 points is going to be the length of the segment, right? So subtracting the 2 x's, I'm going to have 5 minus negative 3. So heads up. There's going to be a double negative there. So I'm taking 5 minus this, right? 5 minus negative 3. Okay, and that's all going to be squared. And then for my y's, here's y sub 2, 8 minus 6. And I'll square that as well, okay? All right, so now I'm going to simplify each set of parentheses. So remember, when you have a double negative, that's going to be the same as a positive, right? So 5 minus negative 3 is the same as 5 plus 3. So I'm going to get 8 squared, and 8 minus 6 is 2 squared. Some people will look at this and they'll say, wait a second, squaring something and taking the square root, those are opposites. So isn't this just going to be 8 plus 2? Which would mean it would be 10. But this is wrong. This is incorrect. Okay? Because I want to simplify all of this before I take the square root. Think of that as a group, okay? So if you think of PEMDAS, I'm gonna do the exponents next, and then I'll do the addition. And the last thing I'll do is take the square root, okay? So 8 squared is 64, and 2 squared is 4. Now I'll add those together, which is gonna be the square root of, oops, on my screen a little bit, square root of 68, okay? And you could just leave it like that. That would be fine for me at this point. Later on, we'll do simple radical forms, so if you already know how to do that, you could do that as well. You could also put this into a calculator. Square root of 68 is about 8.2 if we're going to the nearest tenth. So either way, doesn't matter. Either for the time being, I take either one of those, okay? All right, last problem. This time we're finding the coordinates of point E. Okay, so looking at this last diagram over here, point M is the midpoint of EF. I know that because these two dashes mean that these two segments are congruent. And if those two segments are congruent, that means M is right in the middle. M for midpoint or middle, right? Okay. So I'm going to use the midpoint formula here. So here is the midpoint formula. This is another one that we're going to use a lot this year, okay? And you can just memorize the formula, but the way I think of the formula, the midpoint is going to be the average of the two x's and the average of the two y's. So if you think about finding the average of two x's, you would add them together and divide by 2, just like if you had two test scores. If you had 80 and 90 for two test scores, to average them, you could add them together and then divide by 2, which would put you at 85, right? And then for the y's, to average those, to average any two numbers, you add them together and divide by how many of them there are, which is 2, okay? All right. Okay, so this is the midpoint over here, okay? So 2, 5 is actually going to go over here, okay? So let's say that the x1, y1 is over here, and then this can be the second x and second y. Again, you can reverse which is your first x and second x. It doesn't really matter, but that's the way I'm setting it up, okay? So I don't know the x1, y1. So I'm going to leave those two in the formula as just x1 and y1. But I do know that x2 is 6. Okay? And y1 plus 7. I know the y2 is 7. So I'm just plugging everything I can into this formula. So now I've got everything from the problem plugged into the formula. All right? So the next thing I'm going to do, the 2 should be equivalent to this first fraction. So I'm going to write an equation. Here, I'm going to split my paper in 2 here for a second, into 2 little columns. So I'm going to write 2 is equal to that fraction. Okay? And likewise, 5 is going to be equal to the second fraction. So I'm going to write another equation over here. 5 is equal to that second fraction. Okay? And now I'm going to have to solve both of these. So I'm going to solve this equation, and it's going to give me x sub 1. I'm going to solve this equation for y sub 1, and then I'll have both coordinates there for that missing endpoint. Okay? So, hey, I'd love to get rid of this fraction. So I've got the top divided by 2. Well, the opposite of dividing by 2 is going to be multiplying by 2. So if I just double the whole equation, well, those will cancel out because 2 over 2 is 1, right? So now I've got 4 equals x sub 1 plus 6. I'm almost there. To get x sub 1 by itself, well, the opposite of adding 6 would be subtracting 6 from both sides. So negative 2 is going to equal x sub 1. Okay. Over on this side, again, I'm going to double to clear the fraction there. So 2 times 5 is 10. 10 equals y sub 1 plus 7. And now the opposite of adding 7 is subtracting 7. That's going to get the y by itself. Okay? And now I've got my x1 and my y1, so I just put them together to get my endpoint. So point E is going to be negative 2, 3. Okay? All right, I'm going to show you a little shortcut. This is a little secret. So another way you can do this, and you actually don't have to use the the midpoint formula for this. Think about going from 6 to 2. Well, it's going down 4, right? So if I subtract 4 from 6, that'll put me at 2. If I subtract another 4, that's going to put me at negative 2. So I could think, okay, well, that's got to be negative 2 then, right? You can do the same thing with the y's. Going from 7 to 5, I'd be subtracting 2. If I subtract another 2 from 5, that's going to put me at 3. Hey, that's the same answer, right? The problem with that is it doesn't work great if you have fractions or decimals or some large numbers. Then it's harder to do that. But you could kind of just do that intuitively like that. Okay? That's all I got for this warm-up.